I did want to show you that I went back in and put a line in here. If you want to print this, you're welcome to, but that line I've added has nothing to do with the graph. It's just dividing the page up. So if you print this and see that, that's all it is. It's just dividing the problems up. Okay, in fact, I shouldn't have put it right here because that goes with the word problem. So let me alter that just a hair. How about this way? Okay. I'm looking on page 205 at the calculator skill. Now, I have been not using those problems because we use a Casio, and these are generally for a TI. But I do want to show you how to use the quadratic formula. Now, some teachers in our level of math do not even teach this, and that's perfectly okay. If your teacher is not teaching the quadratic formula, you don't have to use this problem at all. But for those of you who are going on to college, you need to have at least seen this formula. And it is called the quadratic formula or the quadratic equation. I think the best term is the quadratic formula. It's just another one of those patterns like slope-intercept and point-slope and linear and all those things that we've learned. This is just another formula that applies to functions. And the instruction on this problem is to use a calculator and the quadratic formula to find the x-intercepts of f of x equals 6x squared minus 7x minus 3. So they want us to find the point at which this function, or points at which this function would cross the x-axis. Okay, so in order to do that, we need to solve this quadratic equation. Now, we've learned to do that with factoring. We've seen a few of those here and there. But I want to show you how to do this on the quadratic formula. So let's put in what we know about quadratic equations, the thing that you have seen. And I'm going to do that right here in this form. So you know that we've seen this is the same as y equals ax squared plus bx plus c. Okay, that's called the quadratic form, the quadratic pattern. So I need to be able to relate these two things together. So let's go ahead and draw a variable box. When I was teaching this kind of math every day, I required my students to use a variable box because I wanted them to not get this stuff mixed in with their problem. But the variables that we want to know are A, B, and C. So looking at this formula, and I'm talking about this one, A is right here. It's the thing in front of the x. So A is positive 6. B is right here. It's the thing in front of the x. So B is negative 7. And C, you guessed it, is right here. It's the constant. So C is negative 3. So I'm getting those values from this equation. And then I'm going to use those values in this equation. So x is, and let's go ahead and make the frame, be careful, just go slowly. So we have a negative b plus or minus the square root of b squared minus 4ac all over 2a. So all I've done there is copy that formula and put in those parentheses for my letters. So b is negative 7. Again, negative 7. A is 6 and C is negative 3. And then A is 6. So we just substitute our values into the quadratic formula. And then we do the math. And I say that like that's a cakewalk. This is not easy math to do. You have to be careful. The bottom will be easier. 2 times 6 is 12. So I'm just going to put that down there. No problem. Now, a negative 1 times a negative 7 is a positive 7. Plus or minus the square root of 49 minus 4 times 6 times 3. Well, I know that 3 times 4 is 12, and 12 times 6 is 72, and that is a positive 72. But remember, they told me to do what? Use the calculator. So do that. I need to find mine. I am propped up in my bed doing these problems. It's 11:30 at night, and I've got all this stuff. I can't find anything. Okay, so let's just keep working it through step by step. So we have negative 7. Excuse me, we don't. We have positive 7 plus or minus the square root of 49 plus 72 is 121 over 12. So all I've done there is combine those two. All right, what is the square root of 121? You can use your calculator, or you can say that it's 11. So we have 7 plus or minus 11 over 12. Now don't panic here. I know that looks bizarre, but trust me, it's okay. We have two different situations going on there. The first one is going to be 7 plus 11 over 12. And the next one is going to be 7 minus 11 over 12. Because this is a quadratic function. It has two x values. It's x squared. So we need to look at both of those situations. So 7 plus 11 is going to be 18. Divided by 12 is, you can do it as a fraction or a decimal, but it's 1.5. So x can be 1.5, which means that 1.50 would be the point. Or if you do it this route, 7 minus 11 is negative, 7, 8, 9, 10, negative 4 divided by 12. So that would be negative 1/3, or negative 1/3, 0. So the instructions were to find the x-intercepts of that quadratic equation, and that would be these values right here. Okay, because in the quadratic formula, you will always have that plus minus. You have to do both scenarios to get the two intercepts. That's a beast, okay? I tell you what, let me do one more of those while we're on this. Let me see if I can find one. I can't just make one up because they don't all work the way I want them to here. If you're not interested in this, that's okay. You don't have to worry about it. 134 and 135. So let me turn back to those pages and see if we can get another example. of the quadratic formula. If you don't want to see this, that is okay. You can just skip this second part. But I'm going to mark off some space so that we're not getting the problems all mixed up together. All right, so here's another example. Let's use this equation. I'm trying to pick one that will be a good one. Let's just do the basic one. Okay, so here we have f of x equals x squared minus 5x minus 14. And we want to use the quadratic formula. So let me write it over here. I'll change colors. It is x equals negative b plus or minus the square root of b squared minus 4ac, and all that mess is going to be over 2a. And by the way, the 2a, never mind, I'm going to leave that. All right, so the first thing I need to do is set up a variable box. And I need to remember the basic quadratic pattern is ax squared plus bx plus c. So when I bring this variable box over here, using those three variables, I have a, b, and c. If you need to highlight, that's fine. A is going to be a ghost 1. Remember, you can put that ghost 1 anywhere you want to. So there's the 1. And then B is going to be negative 5. And C is going to be negative 14. Okay, so this formula gives me those variables, and then these variables plug into this equation. So let's plug carefully. It's important. So we have x equals negative b plus or minus the square root of b squared minus 4 times a times c, and all over 2 times a. So I've just substituted my values in there, and let's do some simplifying. Negative 5 is the same as positive 5, plus or minus. Negative 5 squared is 25. Negative 4 times 1 times negative 14 is positive 56. And all of that mess is over 2. 2 times 1 is 2. Don't try to simplify all in one thing. Do it a step at a time. So then we're left with x equals 5 plus or minus the square root of 25 and 56 is 81 over 2. Okay, the square root of 81 is going to be 9. So we have x equals 5 plus or minus 9 over 2. And once you get it to this point, that's where you separate them out. So we're going to say 5 plus 9 divided by 2, or 5 minus 9 divided by 2. 5 plus 9 is 14 over 2, and that's 7. So that x is 7. The intercept is 7, 0. And then 5 minus 9, that's negative 4 over 2, which is negative 2. And that would be negative 2, 0. So given those values of x, you can come up with the point if you need it to graph. Or if you don't, you just say x is 7 and x is negative 2. Those are the two solutions for that equation. And I have room, so let's do one more, just for those who want to know this. Again, if you don't want to know this, you may totally skip these. But those of you who are going on to college and you will need to know, this is a good one to know. All right. Let me not get in a mess here. Okay, here's one. 2x squared minus 10x plus 9. Let me use function notation. So f of x equals. All right, I recognize immediately, and I'm sure you do too, that this is in quadratic form, where f of x equals a times x squared plus b times x to the first plus c, the constant. So set up a variable box, and I do encourage you to do that so you don't get this stuff mixed up into your problem of a, b, and c. A is 2, b is negative 10, and c is positive 9. So 2, negative 10, and positive 9. So we use that form to get those variables. And then we need our quadratic formula. X is negative b, plus minus the square root of b squared minus 4 times a times c, all over 2a. And then I'm going to carefully substitute. So x is negative 10 plus or minus the square root of negative 10 squared minus 4 times 2 times 9, all over 2 times 2. So x equals positive 10 plus or minus the square root of 100 minus 72, all over positive 4. Then x equals 10 plus or minus the square root of 100 minus 72 is 28 over 4. Okay, now the square root of 28 is not an even square root, I don't think. Let me see. No, it's 5.291502. Okay, so at this point, I'm going to say that x is approximately 10 plus or minus 5.3 over 4, because I have to round that square root. Now, you can work with it as a polynomial, but I'm not going to get into that today. That's a little bit more than we want to do. All right, so let's do 10 plus 5.3 divided by 4. So you have 15.3 divided by 4. So x is approximately 3.825. And then 10 minus 5.3 divided by 4. 10 minus 5.3, divide that by 4. So x is approximately 1.175. That one's just ugly. But it will work using that quadratic formula. So if you need more help with that or think you're going to need more help with that, please talk with your instructor and he or she can help you with some more examples. There are also some in this textbook. If you look in the index, you can find more about the quadratic formula. Okay, I'm going to stop this video. It got longer than I thought, but we have one more example on page 205 to do.